Hello everyone and welcome to Wildcard Workshop. Today we're going to be talking about logic, data, and inheritance. I have to confess something. I have recorded this video several times now. This one was particularly difficult for me because my own education was unconventional in this subject. So a lot of these concepts are difficult for me to articulate. I debated quite a bit over whether or not I should even do this particular video, but in the end I came to the conclusion that even if it's not great, if I can get across some important information and give that shift in how you might be looking at programming to get you in the right mindset for it, then it would be worth it. So as you're watching this video, rather than focusing on a lot of the technical aspects that I might bring up, I want you to look at it in the context of the overall view of how these different systems are interacting with each other. Okay? I want you to focus on how I equate some of these concepts to real life equivalence. That is one of the things that took me the longest to understand when I actually started programming. I didn't really have a teacher to kick me upside the head and say, hey, you're looking at this wrong. Shift it just a little bit. Just shift the angle that you're viewing it. So it took me a long time to understand some bits of this that I'm going to cover today. And articulating them, as I said, is still difficult for me. I'm not qualified to educate people on computer science by any means at an advanced level. So if you continue watching this video, understand that. There might be slight inaccuracies in terminology that I use or the way that I verbalize things. If you have any recommendations for how to make this video better, go ahead and put them in the comments. I may come back and re-record this video as I get better with making these tutorials. But I thought it important to cover this during the early videos. With that out of the way, this particular video is going to cover, like I said, logic, data, and inheritance, and how those things fit together in UE4 and the Arc Dev Kit. Let's go ahead and go in and see how it all works. To start our intro to blueprinting, I've created two blueprints here. Now remember, as I said in the last video, blueprints are classes. Treat them as such. The one that you'll probably be working in most commonly with modding is actor blueprints. Actor blueprints are blueprints that can have a physical presence in the game world. These are things like characters, structures, creatures. These are things that you will find in the map as you play. Okay? Now, if we open up our Actor BP, actually first, if you want to make these for yourself to follow along, all you have to do is right-click in the content browser, go to Blueprint, and you'll see up here there's an actor. It's also down here, and object. So just create two blueprints, one where object is the parent and another one where actor is the parent. And that will give you these. So once we open up the Actor BP, you will find that there is a bunch of stuff already here in the defaults. These are variables that are inherited from the actor class. Okay? Remember we mentioned inheritance in the last video, that these were things that you get from the parent. So the parent actor class has all of these variables already on it. And if you go to the Graph tab, you won't really see them. You'll see these overridable functions. These are also inherited from the parent. But if you want to see all of the inherited variables here in the Graph section, you just click that Show Inherited Variables, and they'll all show up down here. Now, a lot of these do many different things. You will want to, if you need to use them, you will want to go into the UE4 documentation to look over any that we don't cover here. But a lot of these have to do with replication, which we'll get into next week heavily. Or some of these are actually base arc variables as well that have been edited into the actor class. You won't find these in base UE4. But these all have their own functionality that's tied to them. A lot of the time we won't mess with these too much, except for maybe where replication is concerned, or whether or not it's even visible, like actor hidden in game, things like that. So for now, let's ignore everything that's inherited. Okay? Right now, we don't need it. So let's just do that and pretend that for the moment, this class is empty for our purposes. If we want to do anything with this class, there's two things that we need. We need data, and we need logic. Now, for data, we store that in variables. So let's create a variable. In the good old-fashioned of tradition, let's create our little hello world program. So the first thing we want is we want to create a variable to house the actual text that will be displayed for hello world. To create a variable in the graph tab, you come over here and find the variable button. You click that and it'll generate one down here. So let's name it hello world string. Okay. Now this variable is the wrong type. Right now it's a Boolean. A Boolean can only have true or false as a value. What we need is a string. Now, this can store text data. Whenever you add a variable to a class, to a blueprint, you need to compile it before it will show up in the defaults. But as you can see, here in the default section, hello world string, and it's empty. So let's just type hello world into it. Now, this data isn't doing anything. Just adding the variable doesn't cause it to print. It's just storage, like a box sitting in your room of old knickknacks. On its own, it's useless. So we need to make it do something. To do that, we will pop over to the graph, and we will add an event. Now, events are triggered externally by, in some cases, the engine or other blueprints. What we're going to do is we're going to look at event begin play, which is a very common event that you're going to use. Event begin play is fired when the actor blueprint, and this is only true for actors. Object blueprints do not have these events. Not default ones anyways. The begin play event is triggered when the actor is created. Like right now we are creating the blueprint, the class. But in game, these classes have to actually be constructed. It's like having the instruction manual for a Lego set and a bunch of Legos. You have to actually take all of the Legos and put them together to create an instance of the object. Okay? So this will be fired when the instance of that actor is created. So we've got event begin play. Now there is a function built in called print string. Now this function, this print string, this is for editor stuff. but it will suffice for our needs right now, just to kind of give an example of how to use data. To use it, we've got our hello world string right here. What we want to do is we want to click and hold on that and drag it into the graph here. And you'll get this little context menu. It says get or set. Now get is when we get the value of a variable, and set is when we change it. So we want to get the value of hello world string since we've set its value in the default settings. So now we want to hook that up to print string, and it is there. Now these are some options available to this function. Print a screen, print a log, and text color. So like if I want to make it red, just to make it a little bit, well, it's not red. That's not red at all. This is, there we go. Okay, now it's red. So now we've got our actor set up to print hello world. To make it actually work, we need to create the actor in the world. The easiest way to do this in testing is to just take your actor BP, your actor blueprint, and drag it into the map. And there it is. Okay? So it will be constructed when the world is. Now we're going to do a quick look at testing. In the editor, you can actually test the stuff that you're working on by coming up here to this play option. Now I suggest that as a default, when you're developing your mods, that you tick on run dedicated server. Remember that Ark is a multiplayer game. It's most of what it's going to do is going to be used in multiplayer servers. So it's best to design around that first, and then you can go back and clean up for single player. If there's any issues with that, you'll find that you have fewer issues if you work with multiplayer in mind first, and then go back to consider single player, rather than starting in single player and working in multiplayer and find out that you haven't done any of the replication necessary for multiplayer to work. And remember, we'll talk more heavily about replication in a couple weeks, but for right now, just know that replication is extremely important to working with multiplayer, and we want to sort of design around multiplayer to begin with. So we have taken our actor BP, we've dragged it into the world. Let's see what happens. If I hit play, it'll load, and it'll probably load a while for the first time. You'll find that once it loads, and up here in the top left, see that? Server, hello world. And then it goes away. So we have successfully done our little hello world program. It's pretty simple, right? Not really complicated. We stored a bit of data, and then we used it. So let's quit out of play in editor. We'll often refer to this as Pi, because one, Pi is awesome, and two, because play in editor. So, Pi. But now that we finished that, we can see this was all it took to just print that string. Another thing that might help, by the way, is if you go up here to Window and Output Log. And that'll put that down there. So when you're testing and if you're using print strings, which I do recommend you do when you're developing, it'll make it a lot easier to debug and find issues. But you'll see that down here, somewhere, am I using the right log? There it is. Okay. Log blueprint user message client 1 hello world. So those print strings will show up down here as well. So that was working with an actor BP. We were able to start an actor BP by having it created in the world and taking advantage of an event that's already being triggered by the engine. If we work with an object BP though, one where it's not an actor type, it doesn't have a presence in the world, you'll find there's actually nothing in it. It is completely empty. So what we do with an object BP is, let's say we create a variable, call it B is a thing, okay? So we've now got this data of a bool, which, if you remember, stores a true or false value. Okay. Let that compile. We're going to say, yes, it's a thing. No, actually, you know what? We're gonna do this in code. Okay. So first things first. Let's create a function. I'm going to call it test is thing. Okay. Now, functions have a few parts here. Okay. Unlike the graph, which is sort of out in the open, this is more of a procedural area where things just go from start to end. They aren't really... Graphs are kind of a weird place in Blueprints. They're like functions, but they can cross over between each other. I don't recommend doing that until you really understand how the event graphs work, which hopefully by the time that we've gone through a number of these videos, you'll have a much better understanding of how the event graphs work and how you can do some weird crossovers of information and make things work there. But for now, let's just keep it so it's a bit like events where things are contained in groupings and they don't cross over between different triggers. But for functions, we have a couple things that we can do with that. First of all, we can pass data into a function. For this particular one, we don't need to. Okay? But we do want to return a value. In other words, when we call this function, we want to get something back from it. In this case, what we want to get is a return value of B, is this a thing? Okay. So you notice I've been putting that little case b, lowercase b, in front of the name. That's for Booleans. That's a convention in UE4 for Boolean variables, and I do recommend you do it. When you name things, you'll notice the lowercase b is not there. That is only for Booleans. So we've got this function, and we want it to return the value of b is a thing. So I've taken that, I'm dragging it, and I'm actually just going to drop it right on there. And you'll notice it automatically hooks up. Very handy. Okay. So we've done that. Now let's create another function. Let's do make thing. These function names are terrible, but you'll understand, I think. So for this one, we do want to take an input. It'll be a Boolean again. We're going to name it B should be thing. Okay. This one will not have an output. What we want to do is we want to take our variable b is thing, drag it over, and hit set. And you'll notice now this has some other pins. So when setting a variable, it does require being part of the execution path. Getting a variable can happen at any time. You can just throw down those gets and they're just instantly accessible. But to set a variable actually takes processor time to do. So it has to actually be part of the execution path. So now we have these two functions, make thing and test is thing. Okay? We're going to save this object BP. All right? Once it's done, you'll notice we have not set that to true. It is currently set to false. In the actor BP, we're going to create a new variable. Now, the thing about variables is that we can take and go and use a class as a variable. Remember, variables have types, and classes define types. Okay? So if I go object BP, what do you know? It's right there. Okay? So now we've created a variable that holds a reference to an object BP instance. When we go into play, this still needs to be constructed. To do that, what we're going to do is we're going to get rid of that. We're going to go construct. It would help if I can spell construct. Might have to. This is another thing. Sometimes when you're looking for a particular function, and this context menu, by the way, you right-click in the graph to get this. Sometimes when you're looking for a particular function, you need to turn off context sensitive. So in this case, I do need to. So I need to go to construct object auto name. Okay. So we'll hook up this pin. We will set the class as. We will set the class at this. Sometimes these will take a little while to load. Okay. Sometimes a really long while to load. That took a few minutes. As a suggestion, I recommend never doing what I just did, which was click on this drop down for classes or objects, especially if it's a more basic type. What I do recommend you do instead is to actually come out here, select the blueprint in the content browser, coming back and doing that thing we did in the last video where we hit this little arrow and it automatically fills it in. Much faster, okay? So now we determined what class, what type of object we're creating. This next pin here, outer, this has to do with ownership. And for now, my suggestion is simply to set the outer to whatever object, whatever actor is going to contain this instance of the object, okay? So in this case, it's our actor BP. So what we can do is we can actually go to self, context sensitive needs to be on for that, get a reference to self. And what this means is we're going to get a reference to the instance of this blueprint that is running. And then we'll just hook that up to outer. Now we have a return value. The return value from construct object auto name is going to be the constructed instance of this class. So what we actually want to do is we want to set that to thing ref. Now, notice we can't hook that up. It's because this is returning an object, but our object BP is not an object. That's just I didn't think it through very well when I named that blueprint, okay? Because that blueprint could have been named Magic Base or something like that. It's no longer just the object class. It is now object plus whatever I put into it. So this variable type does not recognize the parent of whatever it's set to. You can set child types in a variable. So for instance, if this was set to object and this was returning our object BP class, that would work. Derived classes can fit into variables of their parent types, but not the other way around. Okay? So how do we get it in there? Well, we have to do what's called casting. Casting is where we try to fit a variable into a particular type. So we want to do a cast to object BP. Okay, and you'll see it right there. So what this node does is it'll try to fit all of the data, all of the information, all of the logic from this other type, from the parent type, down into a more specific type of blueprint. Now, if it's correct and the object type that it's returning is actually the desired type, it'll come through this execution pin, and that'll be fired, and we can store it there. But if it's a different type than object BP in this case, if we had another class that was, say, magic base, and we had instantiated that and tried to put it through this cast object BP, it would fail. And that's how that works for casting from... It's a bit like trying to fit one of those circular wooden blocks through a specific hole. And like the kids' toys, okay? You're taking a block here that could be of any shape, and you're trying to fit it through this specific shape, okay? If this particular object is not the right shape, it's going to fail the cast, and then you'll have this execution pin fire. If it does fit, it'll go through here, and it'll return that object cast as that type. So now we can store it that way. Okay? So now we have set our reference. Okay? Our reference should be valid. This is a good habit to build. Okay? Whenever you're going to be dealing with object references and actor references, it is always a good idea to use this is valid on it. And what this does is this checks to make sure that the object is not null, or that the variable is not null. Okay? The variable, as I said before, it does not have an actual instance of the object in it by default. It has to be created first. Until the time that it's created, the value of that variable is actually going to be null. And if you try to do anything with it, it could actually crash your game. So this is a protective measure. This is valid. If there is a valid instance available in that variable, then this will fire. If not, then here. And you can adjust your logic as necessary in response to that. So if our instance that we've created here is valid, okay, then what we want to do is we want to make thing. Okay, so now we are calling the function that we made before. Okay. If make thing is called, we want it to set it, that value of that variable that we created over here in object BP. This, we want to set this to true. Okay. And then we want to get that value. So we'll do test is thing. That was the name of it. So now we are grabbing that value. And then we just want to print it out again. Print string. Now, we could convert just like that. Another thing that we could do is we could do a branch. This is a logical operation where if the condition is true, then we might print hello world. If the condition is false, then we'll print nope. So there we go. We'll run with this for right now. Okay. This was a lot of information. So let that compile. We've got our object BP. We're good to go. All right. So we'll run Pi again. Remember, our actor is already in the world. It's right over here. So we'll hit play, and we should see hello world again. There we go. Server, hello world. Okay? Right down there. Somewhere. Yep, right there. Hello world. Okay. Now if we stop this, and we, just to prove that this is actually working correctly, if we stop this, we go back to, whoa, don't separate on me there. And we go back here, and we say, we turn off should be thing, recompile. And we run it again, we should see nope being printed out instead. And nope, there it is, right there. So we have covered a lot of information, okay? And a lot of it not in great detail. But I wanted to give you sort of an overview to get started with understanding how the interactions between data, logic, and classes work. We have created an actor and taken advantage of the engine level events that are fired in order to trigger our functions here. But essentially, the thing that you need to understand is that this is being called from somewhere, okay? This is being called external from the actor as like a function. Any logic has to be called from somewhere, and at the root, everything is just being called from a long chain of functions going all the way back to the moment that the program is initially started. And in a procedural manner, it does this process of, okay, I've started. Oh, look, I have some instructions for creating some basic objects. Let's do that. And then it just sort of cascades into this snowballing craziness that becomes a game. We've covered data and we covered logic. And we've referenced inheritance, but this is also something you need to understand. And it's extremely important. If you go into your window and you go into Class Viewer, you will get a gigantic list of blueprints and classes that the game is made up of. Once that's loaded, come up here to Filters and uncheck Actors Only. Okay. What you'll find is that for some reason it doesn't want to show anything else. But so all of these types inherit. These are all children of the object class. Okay, these first level ones. This is one big hierarchy of how everything is related. At the very root, it's the object class. And then it goes to actor. And these are all sibling classes, okay? They're children of object, but they are not children of each other. Now, if we expand actor, for instance, we'll find a bunch of children of actor. And each one of these inherits all of the variables and functions of actor. And if we come down here to brush shape and volume, these inherit from brush. And all of these inherit from volume, all of the functionality, all of the variables. They're all brought in this sort of cascading chain, kind of like an onion, okay? Every layer of an onion, the onion gets bigger, okay? It's always a process of addition and just carrying all of the common data. So if you have, let's take a concept of magic in the game, for example. Say you have a base magic class. Your base magic class could have variables of, say, power or name, casting time, things like that. So you'd want to put all of those variables in the base class so that they're all automatically inherited by the child classes of specific magic types. Okay? That's how inheritance works. It is a carrying forward of common data and common logic so that we can make our lives a lot easier with managing all of these different object types and having them communicate with each other. Inheritance is much simpler than it looks. Like, I understand that there's a lot of classes in here. A lot of these are game specific or mod specific in my case. Like, these are all from a mod. But it's really not all that complicated. Think of it in the same sense of people. You inherit your parents' genes. You inherit properties of your parents. It's very much the same concept. They might have different implementations. They might be, those properties might be used different ways by the child classes, but you're still inheriting them. So that was inheritance. We've covered creation of classes, populating those classes with data, and then using that data in logic. Okay? Those are the basics of how to make things happen. There's a lot more complicated information. There are tons of data types. We'll cover a lot of this stuff as we're going through making our mods. Anything that we touch on. But if there's anything we don't touch on, feel free to use the resources that I referenced in the first video. And that, my friends, is all there is to it. Like I said, I may not have explained some of this in the most appropriate way. So, by all means, if there was better ways to explain some of this stuff, educate me. I am perfectly open to learning better ways to articulate these concepts to people. In the next video, we're going to actually build our first mod. We're going to take it from where it is now, where it's just those base minimum required files, to something that when we go to upload and cook it, that it will work. So until next time, happy modding.